Okay, hi everybody! Welcome to Graphing Rational Functions Day 2. So, Ms. Koski was just here. Say goodbye to Ms. Koski! She was just helping me set everything up.
Hi everybody!
I don't know if I can see you. Anyway, I was just having some technical difficulties, so I think I have it all sorted out now. But yesterday when we were talking about these functions, every single problem had the denominator, power was bigger than what was happening in the top, or the numerator. So like if I have x plus 1 over x squared plus 2, remember that if I plugged in really big values for x, that this was just going to approach 0, so the end behavior, or we also talked about another word for end behavior, which is horizontal asymptotes. Yesterday they were all at y equals 0. So today what we're going to talk about is when the horizontal asymptotes move up and down. Woo. So notice that yesterday every single problem was the same. When you looked at the two biggest powers in the problem, the power on the bottom was always bigger than the power on the top. So today what's going to happen is when you look at the problems, oh look at this. The biggest power is 2x squared on the top, and then down here it's x squared on the bottom. So that means basically if I'm plugging in really, really big powers of x, all of this stuff after the biggest powers is not going to do anything. Doesn't matter at all. Like if I'm going to square 1,000,000, if I subtract 8, it's not going to make a difference at all. So we're not even going to worry about everything. We're only going to worry about the two biggest powers. And so then, if I say that this is really going to approximate 2x squared divided by x squared at the extreme ends of the function, you can see how these are just going to end up canceling out, and all my y values are going to start approaching 2. So basically, the easiest way to think about it is anytime you have the power on the top and bottom equal, so when the powers on the top equal the bottom, all you have to do is take a ratio of the coefficients. For your horizontal asymptote. So here, all I had to do is just look at this and say, oh, 2 to 1, so my horizontal asymptote is at 2. So let's see if you guys can follow along with these ones. Here I have 4x squared divided by 2x squared. So again, I have the situation where the powers are the same. So I just take the ratio of the coefficients, so my horizontal asymptote is at y is equal to 2. So it's going to shift up 2 instead of approaching 0 at the end. And then here, you have to be very careful. Don't always just look at the first number. Let's look at the whole thing. So here, my biggest power on the top is negative x squared, and my biggest power on the bottom is positive x squared. So the ratio of those coefficients is negative 1 to positive 1. So my horizontal asymptote is going to be at y is equal to negative 1. That's not so bad. And then this one again, just look at the biggest powers. So here I have 5x squared, and here on the bottom I have negative 3x squared. So the ratio of those coefficients, my horizontal asymptote, is at y is equal to negative 5/3. Okay? So that's what happens when the powers are the same. So now let's go through some examples. So nothing else changes in any of the problems that you're doing. Everything is exactly the same except for the horizontal asymptote. So we still want to find vertical asymptotes, zeros, holes, y-intercepts, but now our horizontal asymptote is just going to move a little bit. So here's the first example. F of x is equal to 2 times x minus 3 times x plus 2 divided by x minus 4 times x minus 1. Okay, so now this one's already factored for us, which is pretty nice. But I see on the top I'm going to have x squared, and on the bottom I'm going to have x squared, but I have this 2 out here, so it's going to be 2x squared divided by x squared. So I can see here that my horizontal asymptote is going to be at y is equal to 2, instead of 0 like it was at yesterday. Then my vertical asymptotes are at x equals 4 and x equals 1, and I have zeros at 3, 0, negative 2, 0. I don't have any holes because nothing cancels out. And my y-intercept, if I plug in 0, I'm going to get on the top 2 times negative 3 times 2 divided by negative 4 times negative 1. So if I do all that, it looks like it's going to be at 0, comma, negative 3. All right, so now let's put all this stuff on the graph. Now I want to make sure that you guys really understand the horizontal asymptotes, because sometimes this is where people start getting confused. Horizontal asymptotes are really only talking about the very end of the graph. So we're talking about on the extreme right-hand side and on the extreme left-hand side of the graph. So don't draw your horizontal asymptote all the way across your graph, because it might confuse you as you're working on these problems. So let's get that all on the paper. So let's see. I'm going to do, here's my xy axis. I'll start with my vertical asymptotes. 1, 2, 3, 4. There's one vertical asymptote. And 1. There's my other vertical asymptote. 0, negative 3 is my y-intercept. And then I have a 0 at 3, 0, at negative 2, 0. And now see here on the extreme right-hand side of the graph, to the right of all the horizontal asymptotes, I'm going to put, of the vertical asymptotes, I'm going to put my horizontal asymptote only on the extreme right-hand side, and then again over here on the left. I'm not going to draw it through the middle, because then it's going to confuse me. Because this only is referring to end behavior, so you don't need to write it in the middle of everything. Okay, so over here, I see that my graph has to be asymptotic on the bottom here and on the left-hand side here. And it's going to go through these 2 points, so it has a portal to cross over the x-axis through this 0. So I can see on the left, my graph looks like this. And then remember, I can't have an asymptote sandwich, so I can't start from the bottom here and go to the top. But I have a 0 inside here, so I have to draw that cubic-looking shape. But it's going to start at the top and then go to the bottom. And then over here, I just need to decide if I'm above this asymptote or if I'm below it. I can't be below it for 2 reasons. One reason is I don't have a 0 to pass through here, and the other reason is I can't have an asymptote sandwich. So I know the end of my graph has to look like this. So everything's exactly the same as what we did yesterday, except the horizontal asymptote is just shifted up above the x-axis. But it doesn't change anything. It only just means, oh, now we're going to be leveling off at a number other than 0. Everything else is exactly the same. So let's try another example. Those are pretty fun. Isn't this fun? Wow, I wish I was here with you instead of in a meeting. Let's see. Let's do example. Oh man, x squared minus 9 over x squared minus 4x minus 5. Well, now this one's a total bummer, because what do you have to do first? What? Oh yes, that's correct. You always have to factor these problems first if they're not already factored for you. So the top is going to be x plus 3 times x minus 3, and then the bottom is going to be x minus 5 times x plus 1. Okay, so now in the unfactored form, it's pretty easy to do the ratio of coefficients here. So my horizontal asymptote is going to be at y is equal to 1, because the ratio of coefficients is 1. So it's just shifted up 1. And then I have zeros at negative 3, 0, and positive 3, 0, where the numerator is equal to 0. Vertical asymptotes, where the denominator is equal to 0, at x equals 5, x equals negative 1. And then my y-intercept, there's no holes in this because nothing cancels out. My y-intercept is just going to be these two numbers here at the end. So when I plug in 0, I get 9/5. Okay, so now let's get all that stuff on the graph. So remember, when you're doing the horizontal asymptote, like in this example before, don't make it go through your entire graph. Only put it out on the ends because it's the end behavior. So let's do this. Let's graph it. Yeah. Okay. Here's my xy axis. I have a vertical asymptote at 5. And I have a vertical asymptote at -1. I have a 0 at 3, and I have a 0 at -3. My y-intercept is 9/5, which is close to 2. Oh, I already see that cubic action happening in there. And then here out on the ends, I have a horizontal asymptote at 1. Okay, so basically I feel like this looks a lot like the last graph we just did. Here, I have to cross over the 0 and be asymptotic, so I can't be above here because I have to go through that, so dun dun dun. I can't have an asymptote sandwich, so now I have to start at the top, go through the y-intercept, and then go through the 0. Good. And then over here, again, for the same reason, I have to be above this horizontal asymptote because I can't have an asymptote sandwich and I don't have a 0 to go through here. So, dun dun dun. There we go. Not so bad, huh? Okay, let's try one more. I know you really like watching this video. You were like, no, more examples. I want more, but I'm only going to give you one more and then you guys have to do some on your own. So here's your last example. F of x is equal to -4x times x plus 3 divided by x minus 1 times x plus 2. Okay, so now I can see here that if I multiply these two together, I'm going to get -4x squared. And if I multiply these two together, I'm going to get x squared. So my horizontal asymptote is going to be at y is equal to -4, because that will be the ratio of coefficients. My zeros are at 0, 0, and -3, 0. My vertical asymptotes happen at x equals 1 and x equals -2. And my y-intercept, oh, it's already right here, 0, 0. Huh, I love it when that happens. That makes my work so much easier. Okay. Now remember, horizontal asymptotes, I am not going to draw it through the entire graph, only on the ends. That's the only place that makes sense, because it's end behavior. Oh yeah. Okay, so let's see here. 1, -2 for my vertical asymptotes, 0, 0, -3, 0, and then, ooh, -4. Okay. Now, I'm going to start on the other side of the graph. I usually, for some reason, always start on the left, but I'm going to start on the right because I know I have to be down below this asymptote because I don't have any zeros to pass through here on the top. So I have to be extremely below. I want to make sure that I follow all the rules of math so I don't get any punishment. No dividing by 0. No passing through the x-axis through just like, oh, I just want to cross it. No, you have to go through a 0. So now let's see. I can't go this way because I can't have an asymptote sandwich, but I do have a 0 between these two asymptotes, so it's going to be the cubic shape, but this time it's going to be rising this way. And then I'm going to have to start from the top, cross through this 0, and then down through to this asymptote here. No. Okay, yay! It's a beautiful function. Life is great. I will see you guys tomorrow. Your homework is Rational Functions Day 2. Now, keep in mind when you're looking at the problem, some of them is going to have the horizontal asymptote shifting, and some of them, they will be at 0. So you have to check The powers. So if the powers are the same, it's the ratio of the coefficient. If the power is bigger on the bottom, then it's just at y equals 0. Okay.